Hello and welcome to the third episode of the TypeScript tutorial on Code with Matt Varghese. In this video, we will cover the topic of operators in TypeScript. Now here we have Visual Studio Code open with the project setup for TypeScript. I cover how to set up projects in a previous video that I will link up here. Whatever we code in TypeScript on the left can be executed on the right in the Linux terminal. We have already seen the assignment operator in our previous video on the basic types in TypeScript. It allows us to assign values to variables and constants. Here we have a numeric variable which is being assigned a value. We can do the same with strings, booleans, and even more complex type constructs in TypeScript. The one other thing to note is that you can chain multiple assignments. So here we have y as well as z getting the value 42. We have this idea of destructuring in TypeScript. In this example, we have an array with 3 strings in it. And then we are trying to declare 3 variables, and we want each of them to be assigned the value of the corresponding element in the array. TypeScript allows for that, and we see that v1, v2, and v3 get the values alpha, beta, and gamma respectively. Destructuring can also be done on objects. Here, for example, we have an object with 2 properties, and then we destructure the properties. The names of the properties must match the names of the respective properties in the object. Now, this destructuring format is normally used for functions where you have a complex parameter passed in, and the function destructures that parameter into the various variables that it needs in its processing. We have our standard arithmetic operators to add, subtract, divide, and multiply. We have our modulus or remainder operator to compute the remainder from a division. We have the exponentiation operator to raise a number to a given power. The arithmetic plus operator also serves for concatenating strings, as can be seen here. And we have been using that in our console log statements above as well. You can also concatenate strings with another type. This leverages the toString method that almost every value in TypeScript has. And so toString on true returns true as a string, and that attaches itself, that concatenates with the string that we have here, for example. Similarly with the number. We have the C++ style arithmetic assignment operators. For example, the plus equal to is the same as x is equal to x plus 10 here. Similar abbreviated versions exist for minus, star, divide, modulus, and exponentiation. The plus equal to also works on strings for concatenation. Here we use the plus equal to operator on a string to concatenate a string onto that and assign it to itself. Remember that TypeScript does not allow modifying strings in place. Strings are immutable. We have the plus plus and minus minus, increment and decrement operators. Here we are using the prefix version of the plus plus operator, so it changes and then uses. X was 14 up here, so plus plus x causes x to become 15, and 15 gets printed in both these situations. So when used as well as after use, it's still 15. Similarly, the prefix version of the decrement operator. Now let's look at the postfix versions of these. So here, because x plus plus is used, x plus plus writes 14, but after that operation, the value of x is 15. So it used and then changed x. Similarly with x minus minus, before this statement, x is 15. X minus minus first uses x as 15 and then decrements it, and so the result after the statement is 14. We have our greater than or equal to, less than, and less than or equal to comparison operators. These all return Boolean values. These can also be used with strings, but use them with caution because they give you the alphabetical sorting order using the ASCII codes rather than a numeric value equivalent or anything of that sort. TypeScript being typed does not allow comparing across types. Here we are comparing string and number. That's not allowed by TypeScript. We also have the equality operator. There are two versions of it, as we will see. Here we have the two equal to signs equality operator, and the corresponding inequality operators are not equal to, but we recommend not using these. Instead, in TypeScript, use the triple equal to or the not equal to operator. These are actually type-safe comparisons. So this TypeScript being typed, I would recommend always preferring these operators. There is no good reason to use the double equal to or not equal to operators in preference to the strict equality, strict inequality operators. The equality and inequality operators also work with strings. We have the logical operators to work with Boolean values in TypeScript. Here we are comparing 100 greater than 10 and 9 less than or equal to 9. 100 is greater than 10, so the left side is true, and 9 is less than or equal to 9, so the right side is true. True and true gives true. However, the above expression, if you notice, is a little bit unreadable. I always recommend using explicit parentheses to designate your operator precedence rather than relying on the implicit operator precedence. Similar to the AND operator, we have the OR operator. Here we have 100 less than 10, which is false, and 9 less than or equal to 9, which is true. The result becomes true because false or true is true. We have the NOT or the Boolean complement operator. One thing to note is that the logical operators in TypeScript short circuit. So for example, for the AND, 100 less than 10 is false, and so I don't need to calculate the rest of this expression to know whether this is true or false. So this side is not executed, and so the plus plus does not happen. And so our value of x remains 14 even after this statement. Similarly, in the OR case, 10 is less than 100. This is true. Therefore, I don't need to compute the other side to know the result of the OR. True and anything is true. True or anything is true. So plus plus x never gets executed, and the value of x remains 14. This short circuit behavior can be used for assigning default values. Here, for example, we don't have a value assigned for unused. So when we try to assign with default, unused is null and therefore it's false. So we use the default value here, and that's what gets assigned to this variable. However, in preference to using the logical OR operator, we have the nullish coalescing operator, the question mark, which serves this exact purpose and is designated for use for this purpose. So here we use the question mark instead. Same thing happens. The default value of with default becomes the value that we specify after the question mark operator. The AND, OR, and nullish coalescing operators have corresponding assignment versions. There is no assignment version for the NOT operator because it's a unary operator. We have our bitwise operators. For example, the bitwise AND will AND bits together. So we have 18, the binary representation is here, 21, 25, the binary representation is here. And so this one remains. This is 0, this is 1, so that goes away. Similarly this and the last one. And so we get 1 0 0 0 0, which is 16. Similarly, we have the bitwise OR and the bitwise exclusive OR operators. Bitwise NOT, or the complement operator, is kind of tricky because negative numbers are stored in a peculiar fashion in binary. We take the absolute value, modulus, and subtract 1. So for example, negative 11 is stored as the complement or binary complement of the absolute value 10. So here, because our bit result previously was 10, when we complement it, we get negative 11. We can actually examine this using the bitwise shift right operator, shifting it 0 places right. So the value stays the same, but it becomes forced into a positive number, and we see the binary representation of negative 11 here. If you look, if 1010 is 10, and so negative 11 is the complement of 10. There is our regular shift right operator. This fills in with the first binary digit. So if it's a 0, it fills in zeros at the beginning. If it's a 1, it fills in ones at the beginning. Shifting negative 11 right by 2 places here, we can see that it still maintains its negativity. It's negative 3. But if we want to shift right with a 0 fill, we can use the 0 fill shift right operator we saw earlier. This prepends zeros, and so the result of this becomes a very large positive number. Similarly, we have the shift left operator. There is only the one version of this. There is no 0 fill equivalent when shifting from the shifting left. It's always zeros that get filled in on the right. For all the operators here except the complement operator, we have the assignment versions similar to the other arithmetic assignment operators that we saw before. We have the comma operator in TypeScript. It evaluates a bunch of expressions left to right, and the result of the last expression becomes a value assigned, or the result of the last expression becomes the value of the whole expression. So here we first do plus plus x, which makes previously x was 14, so plus plus x makes it 15. Then x plus 5 really does nothing because x plus 5 is 20, but it does not get assigned to anything, so it does nothing here. And then x is still 15, and x minus 1 gives 14, and that 14 gets assigned back to x, keeping the value of x the same after this whole sequence of operations. We have an interesting operator in TypeScript and JavaScript called the spread operator. Here, for example, we have an array, and then we have a function which again uses the spread operator to define rest parameters. So I can pass this function any number of parameters, and it'll get all of those parameters consolidated into an array. Now I'm calling this function with the ... array, which means this is not passed as an array itself, but the values are spread out as individual parameters into the add function, and then this second spread operator coalesces them back into an array. The spread operator also works on an object. Here, for instance, we have the object 2 we defined somewhere up above here, and we are defining object 2 based on that object. We're spreading out the object, so the properties of object become top level properties in this, along with another property that we are defining here. So if you look, we have top level properties x, y, and z because object was spread out when defining object 2. The conditional operator is a ternary operator. That is, it takes 3 parameters. The first is a Boolean value, which usually is a conditional expression. The second parameter is the result if this condition is true. And the third parameter is or third operand is the result if this condition is false. So now here x is true, therefore the result of this becomes the string x is 14. We have a few other operators of note in TypeScript. We saw the type of operator in the last video, and that's also being used here along with the key of operator to define a variable of the type of the keys that are in object2. If you try to define key as a string, etc., TypeScript complains because the type of the key of object2 is a union type of 3 constant values. Then we have the instance of operator. Again, we saw this in the last video along with the new for define check. Instance of was used for checking if something is an array. New was used to create arrays and objects. In operator was used, for example, in for loops where we check whether a property is in an object. The void operator is a special case. We don't really use that all that much. This, when used as mentioned as an operator, is different from when used as a type. So as the operator, we don't use void very often. We use it often as the return type of functions, etc. Then we have this optional chaining operator. So let's say we have an object. We are defining its type to be either an object with a property p or undefined so that we cannot initialize it. And then before assigning, if we do object x question mark dot p, object x does not, it is undefined, and so it does not yet have a property dot p. This doesn't fail, it just causes this to be undefined. But after we assign a value, the object x question mark dot p returns the value of the p. So if this is not null, dereference further and get the p. And this can be used in long chains where you have object x question mark dot p question mark dot some property inside of p question mark dot some property inside of that nested property, etc. So it's kind of a handy property to write the null check into an assignment operation. We have a few other operators like yield, await, etc., which we will see later on. Let's take a quick peek at operator precedence. Here in this expression, does the 100 divided by 2 happen first, causing the result to be 50 plus 50 is equal to 100? Or does 50 plus 100 happen first, causing the result to be 150 by 2, 75? We know that the division operator takes precedence over the addition operator, and therefore the result here is 100. However, I recommend against using the implicit operator precedence and being explicit about your operator precedence using brackets. So here, for example, we added brackets around the 100 by 2, making it explicit that this has precedence. You'll see a lot of folks beating the dead horse on operator precedence, having tricky problems and questions presented and all that kind of things. But why? Always be explicit about your operator precedence. Always use parentheses when there is even a remote chance of things being unclear to somebody looking at it. If you're curious, this developer.mozilla reference that I have here is a good reference on operator precedence for JavaScript. Remember that not all of these operators are recommended for TypeScript in the exact same fashion as in JavaScript because we don't compare across types ever. But like I said, always use brackets to be explicit about your operator precedence. So to wrap up, we covered operators in TypeScript. We specifically called out the JavaScript operators we do not want to use in TypeScript, and also talked about being explicit about our operator precedence. All of the code that I used in this tutorial are available on my GitHub repository. If you like this video, hit the like button, hit the subscribe button so you can get the new videos as I release them, hit the notification bell. And if you have questions or comments, either add them as a comment on this YouTube video or post them as issues on the Git repository. I will post a link to the Git repository on this YouTube video. And I will see you guys on the next video, which I think will be about decisions and loops. Important constructs before we go into things like functions, modules, object-oriented programming, etc. So right now we are laying the foundation before we go into advanced concepts. Thank you guys.